What's up, YouTube? In today's video, we're going to be looking at worker services in .NET Core. Sometimes they're called background tasks, sometimes they're called background workers, background services. I'm going to call them worker services because that's what the Visual Studio Project Template is about. We're going to be looking at some low-level stuff. I'm going to explain to you what and how about the worker services. We're going to build our own worker service from scratch, as well as from the project templates. And we're also going to be building a worker service that is more real world. It's going to be listening to, in this case, a RabbitMQ queue to receive messages and process messages. And we're going to take that same worker service and host it as a Windows service that can be also a daemon on the Linux platform and can also be hosted from within an ASP.NET Core application. So we're going to take this thing through various spaces. All right. So let's get started. What is this whole thing? There's the idea of an application, and then there's an idea of a hosted service. So ASP.NET Core is a hosted service within an application. All right. In other words, there's an application that's running, and then that application hosts other services. In this case, it's ASP.NET, or if it's SignalR, the same idea. There's a hosted service where the hosted service's lifetime is essentially controlled by the application, the main thing that's running that controls the lifetime, initiates the service, and also gives it a way to gracefully shut down the service. Before this whole idea, there was always a feature of a possibility to create your background tasks or background services. But the main problem was that they would not have a way to gracefully shut down things. So they would just be killed or kind of left open depending on how you implemented it. So the idea with the hosted service is that they are controlled by the lifetime of the application that's running them. And the application in turn will start it and stop it when it's shutting down and give the opportunity to your background services to gracefully shut down, meaning dispose of various things, close off files or flush files, and dispose of the handles, stuff like that. So prior to .NET Core 2.1 or 2.2, we used to have the notion of an iWeb host. These were hosted applications that were very web specific. They dealt with servers, HTTP servers and such. Since 2.1 or 2.2, we now have a iHost that is independent of web things. You can certainly make web call HTTP client calls from your hosted service or worker service, but it's not tied to the rest of the ASP.NET Core infrastructure with regards to web applications. You do get access to the configuration system, the dependency injection system, the logging system, and things like that are independent of web, but you don't need to have the whole kind of dependency on the web infrastructure with an iHost. The basic idea then is you host your hosted service in an application. It's really any class that implements the IHostedService interface. We get a base class that has some basic implementation for an iHostedService that you could use. That provides you with some infrastructure or plumbing for tasks. But basically, you can build your own, and we will be doing that in today's video as well, where we'll use the base class that's provided to us within the .NET framework, but we'll also build our own from scratch just to get a sense of, what does it take. And I'll also show you the code of the base class that's implemented in .NET Core, so you get a sense of what it's doing for us, all right? And then we're going to take that through its spaces and eventually move it to a ASP.NET Core application. I'll talk about some of the pros and cons when you should or should not do some things in ASP.NET Core application with regards to worker services, and sequence matters, so you want to be aware of that as well. All right, so without further ado, let's get started with the code. All right, so I've just started Visual Studio. I'm going to pick a new project, and in here I'm going to look for worker, and I'm going to pick this worker service template. Okay. This is the .NET Core 3.1. All right. So let's look at some of the stuff that has been done for us. So I'm going to look at the program CS file. Now we've seen this class before. The code here before is very similar to what we would see in an ASP.NET Core application, which is correct. It's almost exactly the same. And the reason is that they're both hosted services in that sense, right? The application is a console application. In one case, it's hosting an ASP.NET Core application. In the other case, it's hosting a worker service application. There are subtle differences where when it comes to the web, the method here that's called configure services, I think it's called configure web services or something. We'll see that. It's just that one big difference here, or small difference, I guess, not a big difference here. And what it's done is it has registered a hosted service called where the class is worker, right? And if you look at the worker class, you'll see that it's descending from BackgroundService, the base class that I was talking about. This is an abstract class, and it has one method that's abstract that we need to implement, which is the ExecuteAsync. And it's called worker. So basically what we've done is we've registered as a hosted service this worker. And here, what they've done, some default implementation is that they've got this cancellation token, and they're looking, going in a loop here and saying if while the cancellation token has not been requested to be canceled, keep doing this. And then here it says, delay, wait for a second, and print out this thing using the logger information. So this is fairly basic stuff. Now, what might not be clear, or the way this has been implemented might seem like, what if? So let's first run this. Okay, sorry. Let's first run this, see how it works, just so you get a sense of how it works, and then I'll start to modify this stuff a bit. So if I run this application, you'll see that it prints out to the console here every second this output, right, which is what we were expecting. Now, what would happen, considering that this is in a tight loop here, in the while loop here, what would happen if I didn't have this in a tight loop? What if I just did one thing and then exited from this loop, or essentially had nothing? The normal expectation for those of us who've been programming in threads or in Windows services and such would expect that as soon as you exit from this method, it ends your application. That's not true of hosted services. Remember, worker services are hosted services. They are not the actual application itself. So, and I'll show you, I've commented out the code here. I'm going to run this application, and we see nothing happens, but the application doesn't actually quit. Right? You can see it's still there. This was a bit of a foxing thing for me, but once you understand that these are hosted services, your worker service is hosted inside of an application, like a .NET Core, a console application, just like an ASP.NET Core application is hosted inside of a console application, or a SignalR application is hosted inside of a console application. So because the lifetime is managed by the application, the console application, it's not going to shut down. When the console application is shutting down, that's when your worker service will also shut down. And we'll see how that happens now next. So one of the things we can override, or one of the methods we can override here, is the StartAsync and StopAsync. So we'll override both of them just so we can see the sequence in which these things happen. Okay, so I'm simply calling the base classes methods here. Now, in reality, what happens is this base class here, the worker service class, it calls ExecuteAsync from startup, meaning startup is called by the application that's hosting this application. And then the background service base class then calls ExecuteAsync from its StartAsync method. And it kind of waits for that thing to finish. And when it comes back with the task, it uses that task as a sensor to know whether you've finished your work or not. When it comes to the StopAsync, it will then sort of cancel that task. And so that if you're using that task within your long running process, now it's shutting down. And so you can take measure and shut down your part. So there are some things you got to be careful of with regards to tasks and cancellation. Basically, you need to understand how to use cancellation tokens so that you're playing nice. All right. So I'm going to just put breakpoints here. All right. So now I'm going to run this application. So first you're going to see it coming into StartAsync, right? And then StartAsync, when we call base, that will call ExecuteAsync. So let's look at that. So now we're in ExecuteAsync. And this, as it exits, it just waits there. Right? Nothing's going to happen. It's not going to come into stop. It's just going to wait here. So it's done. And we're waiting. When we plan to shut down or attempt to shut down the application here, that's when it comes to stop. And then that's when it shuts down. Now there's a caveat to that as well, which is, it's not that much of a caveat. It's just something you need to be aware of. The main application that's hosting your service will wait only for a finite amount of time on the StopAsync part. So it's got a 10-second timeout. Sorry, 5-second timeout. So in 5 seconds, it's going to kill your application. So if you haven't finished off with your cleanup process or whatever you need to do with your disposing of things and it takes longer than 5 seconds, your app, that service, worker service, is just going to be killed. It's not going to wait for it endlessly. Now, in the documentation, they talk about how to extend that timeout, and they make it sound very simple. I have not found a way to extend the timeout for this purpose. So I've tried everything, that I can think of. Not that I know a whole lot here, but besides the documentation, I've tried other things, and none of it actually works to extend the timeout. It works as in it compiles, but it doesn't actually extend the timeout. So it's not a big deal, but something you should be aware of. 5 seconds. So I'll show you how I know that it doesn't extend it, because if I come here, for example, so I run this application, right? So now it's running. Now what I'm going to do is when it comes to the StopAsync method here, eventually, right? When I attempt to close this application and it comes to the StopAsync method here, I'm just going to hold on to this breakpoint, as in I'm not going to step through. And you'll find that the application just shuts down by itself, right? After 5 seconds. Okay, so it's here. I'm doing nothing. I'm just waiting. And at some point, 5 seconds are over, and bang, done. So that's the thing. So even though you might be doing something in this method here, but it's taking longer than the 5 seconds, it's not going to give you that more than the 5 seconds unless you can extend that time if you need it. So in case you have to, flush out all the files and make sure all your transactions are committed and various other things, that takes a whole lot of time. Hopefully you don't write that complex code in this thing. You may not have, 5 seconds may not be enough, but something to know. Okay. Now I'm going to, instead of using this worker and a background service, what if we built our own from scratch? All we need is something that implements IHostedService. That's it. You don't have to descend from this background service, even though it's a good thing that we have a base class available to us that does some of the basic stuff, but we don't actually need to descend from this. So what I'm going to do next is going to build our own hosted service that really just got a timer instead of in a loop here, like we had in this class here. Instead of going in a loop, seeing if this cancellation token is requested, we use a timer and fire an event every second and do something in that event. All right. Okay, so I'm just going to define a new class in this project. It's just a class. So I'm going to call it timer worker service. All right. And this class needs to implement IHostedService. Oops. And it also needs to implement iDisposable. Okay, so if you look at IHostedService, you'll see that it has these two methods, StartAsync and StopAsync. As I said earlier, that there's no ExecuteAsync. The ExecuteAsync is called by that background service base class from start. Right? So, but by default, the hosted service has no ExecuteAsync. It's got a start and a stop. And these methods are called by the host, the application, the main application, the iHost, that you're hosting your worker service into or with. So that main application calls start and stop when it is started and when it is stopped or is stopping, right? So that we have to just implement these two methods. So let's implement these two methods. Actually, we also need to implement iDisposables, dispose. Okay, post these things in alpha order. I'm not sure that's the best way to do it. I like my dispose and things to come at the end. All right, so let's define a constructor. And in the constructor, I want to get a logger so I can log things to the console here. So we'll get an iLogger of this, and we'll call it logger. Okay. And when we start, what we want to do is create a timer, a .NET system.threading.timer. Make sure it's that timer. There are, I think, at least three timers in .NET. So make sure you use the system.threading.timer. That's the one that's thread safe. All right. So in the StartAsync method, we're going to create an instance of the timer. We're going to set up the period or the duration for the timer, and then we implement that timer event that we ask it to call and do some logging in that. And in the StopAsync, we stop the timer, and the dispose, we'll dispose the timer. Right? Pretty simple. So let's do that. So here we're going to have a timer. I should probably define this timer. Hopefully this timer is a system threading the timer. Where did I pick it up from? Yep. Okay. New timer. And it takes a timer callback, and then there are other overloads here. Let's take a closer look. Yes, the other overloads are taking an optional nullable, not optional, nullable state, and due time and period in the form of ints, longs, or time spans. Okay, so what the heck does a timer callback look like? So let's look at that. The signature. One would think you'd remember all these things, but I don't actually remember all these things on the top of my head. So, okay, so it's just a method, like a delegate that has a argument of type object. They call it state, and it's a void returning method. All right, so that's what we need. So we shall define our own method here. Could be private that returns a void. Let's call it onTimer. That takes type object, and they call it state. The state is a way for you to sort of provide the state from here to the callback. So for example, if I want to send the cancellation token as part of the state, so that when I'm in the event, I get access to that cancellation token to see if that cancellation token has been canceled. I can pass that cancellation token as a state. Now, let's just do it. Didn't want to use that and make it that complicated for now. So this will be called onTimer. Right. Then the next argument is object state. So we'll give it the cancellation token. And then let's use the time span version here. So the first argument, I think, is saying the due time. So it should be due in after 5 seconds after creation. And then the period of the timer is also 5 seconds. So that's what I'm thinking. It's going to, after 5 seconds, it fires the first event. I don't want it to fire the first event immediately. Wait for 5 seconds after it's been created and then fire the event. And over here, we just use the logger to log something. Log information. We say called. We're not using the thing here, but you could have a check to say, if it's not been canceled only, then do this part. All right. Now in the stop here, we need to kind of turn off the timer and then get ready to do the disposing. The disposing, we'll do the timer.dispose. It could be null depending on when it gets called. So let's do that. Anything else to dispose? Okay. So in here, we just need to basically shut off the timer. It's not necessary, but let's try it. So here we can do an on change. I think it's called change the, the period and all that. And we say timeout.infinite. So basically the duration is infinite and the period is 0. So basically the due time, as in don't start forever, and the period is 0. So it never triggers again. You don't want it triggering while it's trying to dispose this thing, because this is multi-threaded. So it could call this thing while it's trying to dispose over here. So you want to first just shut it off. I think that's all that is required. Oh yeah, I think we need to return a task. See, that's complaining here. So if you did something asynchronous, then we wouldn't have to return a task. Let me just show you what I mean. So if I did, let's say task.delay, and let's say I delayed for 100 milliseconds doing some work, actual work here, and I awaited this, and I made this asynchronous. Actually, this is, yeah. So then I don't need to return anything, because in asynchronous method, a method that's marked with the async modifier, a task return is like a void return. You're not actually returning anything. You're just, because you're waiting this method. If the method is not asynchronous, you actually have to return a task. It's not some piece of, like show. It's actually, you got to return a task. So if I undo this, then I don't want this to be asynchronous, since I'm not actually doing anything asynchronous. Then over here, it's saying, okay, but where the heck are you're not returning anything? So we need to return something here. Task dot complete task. Okay, so we return that. And in the dispose here, we can also, should probably log, just to be clear here. So let's do, this is StopAsync called. I don't think we'll see any of this stuff. And here we'll say dispose called. Okay, so you got our own, same thing here. We need to return the completed task. We implemented our own implementation of IHostedService and an iDisposable. It's called timer worker service. Now we're going to register this timer worker service with our hosting application so that it can host this for us. Oops. And I could need to just repeat it like that. And hosted service and give it our timer worker service. Now both are registered, meaning the original worker is also hosted and so is our timer. So they're both going to write to the same logger. So maybe you just shut down one, but we can see how it looks. It'd be like a clutter of events, one coming every second, the one coming every 5 seconds. But we actually turned this off for the actual worker, so that's cool. Okay, there you go. So every 5 seconds, we are seeing the timer put out this thing. And so, of course, in the other case, we don't have, let me actually turn this off, I mean, the uncomment out this code. So this will come every second. It'll be a bit of a clutter, but that's fine. Okay, so now I run the, so remember both the things are being hosted, both the services are being hosted. So one's doing this one every 1 minute thing, and then every 5 seconds, we should get the timer part. I'm not sure you're able to see much. That's the on timer event here, and so on. Right. So both background services are working perfectly fine, independent of each other. They just both happen to be writing to the same logger. So that could be a bit confusing. And they're both hosted by one application. So what I'm trying to get across is within a .NET Core application, console application, or a host, it can host multiple worker services, right? And that's something you might want to think about from a design standpoint. If you're architecting some applications that require multiple worker services, you might want to do that. Keep in mind that those background services are using the resources of your main application. Okay, that's one aspect. The second thing is if you're deploying to the cloud, you got this one box with your, let's say, your application that has these two workers services running in the background. In the cloud, you typically have multiple instances of your application behind a load balancer. As you scale out horizontally your main application, these background services are also scaling out. That may not be something you want, right? That's not necessarily, it's not always that one-to-one correlation between your application and the background services. You probably want one instance of a background service, but you want multiple instances of your actual application. So that may not work out for you in that sense, but so keep in mind that that's very different. Web jobs are slightly different in that, and I think web jobs are retired. I'm not sure. They've been deprecated. I can't be sure. But with web jobs, you could actually have them hosted separately, in a separate instance. With background services, that's not the case because they're running in the context of some applications. So if you already have an application in Azure, let's say, that has multiple instances deployed, each of those instances have these two background services, and they could be competing with each other to do the same thing because each background service is doing the same thing, right? And the other part to think about is that your applications need, or the rate of scale, unit of scale, is not the same as the services unit of scale. So you don't need as many services as the application and vice versa. Maybe you need more services than you need application instances from a scaling standpoint, right? So you got to consider all of these things. But we'll see how we can use the same services in an ASP.NET Core application. All right. So if you get this basic idea of our own hosted service or using the background service class, base class that's available in .NET, the next step is to build our own application, own service. We'll use the background service as a base class. But I want something more real world. I want to build a RabbitMQ listener. So then we publish messages and we listen to these messages and make sure we receive them in our worker service. Then we're going to take this worker service and make it a Windows service. We're going to install it in the Windows infrastructure as a service. It will be a daemon in Linux, if that was the case. And then have it run and see it do the same thing. That is basically receive these messages we publish and make sure it consumes the messages and does the right thing while it's a service. And the reason I'm saying this is that Windows services don't have a visual anything. You're not going to see it. We're going to find a way to determine that it's actually happening. All right. And once we have that working, we're going to take that same application and make it hosted in a ASP.NET Core, normal ASP.NET Core application. Right? So we'll take the same code base and just basically I'm going to make this in a separate assembly so we can just use the same assembly in a web application as well. All right. So shut this down. Okay, so we don't need this timer one. I'll leave it here. So maybe when I'll make this code available on my GitHub. So I'll leave all this code here like this, and then you guys can pick and choose what you want to see in case you want the timer version of it. Okay, let's add ourselves a new project, and we'll use a standard library. Standard class library .NET standard, and we'll call it RabbitMQ subscriber worker. Okay. Now, while in the other project, a lot of the Microsoft extensions, hosting, and a bunch of other NuGets were implicitly as part of the project template. Here we're going to have to implement all of those things or let's reference all those NuGets ourselves, right? So it's going to be a bit rough when we start off. So the first thing I'm going to do is I'm just going to call this class RabbitMQ subscriber. Okay, and this RabbitMQ subscriber should be descending from our background service. This background service is another assembly. Microsoft.extensions.hosting.abstractions, really? Okay, I thought it was just hostings, but maybe. Okay, and then this thing needs to implement the ExecuteAsync. All right, so that's our basic background service. And now that we have the service, we should be able to register this RabbitMQ service with the console application that we had here, the worker service part here. So of course, then we'll have to reference our library, add project reference that library from the worker service application. So that over here, we could do that and that. All right. So now the worker service, this project, is using the RabbitMQ subscriber worker from this .NET standard library project. Okay. And here in the project here, again, I want that logger and stuff. So we'll ask for the iLogger. This time it will be the RabbitMQ subscriber worker. Now I'm going to show you our original code that we built a few videos ago. And we're going to copy that code in here and make a few changes. Yes, type. Okay. Okay, so let's open the other project. So if you haven't seen this project I'm talking about here, the RabbitMQ message broker projects, please take a look at that project. There's a series of videos on message brokers. I'll put a link to them all over here. The code, the source code that I'm looking at here also is available in my GitHub. So once you go to those videos, you'll see the links to the GitHub that contains that source code. I'm just using the same source code here. And I have the subscriber. So if I look at this subscriber, it's got this basic subscriber implemented here. But in our case, we want a start, maybe an execute, and a stop. So we want to break this down into like different steps. Where we start, we do something, and when we stop, we do something else, right? So at the time of starting, maybe we should start listening. And at the time of stopping, we should dispose of our connections and various other things that this RabbitMQ stuff has over here. So essentially what we do is all of this needs to be done. So after the basic consume, we should be disposing of our channel in this case. So this should go into the dispose. For that, we need the consumer tag in there. So I'm going to copy this code over and then make some changes, so that we don't lose. So this is all currently in one method. We're going to split it up into two different methods that have. So I'm taking the subscriber code, and then I'll use the publisher here to publish messages so that the subscriber that we build in our worker service will receive those messages. All right. So in the execute, I'm going to just plonk all this stuff in here, right? For now, it's not going to work because we don't have RabbitMQ. So let's even get RabbitMQ installed, NuGet installed. So RabbitMQ. Okay. That's that. So now if we say connection factory. Oh, which project did I install it in? Okay, I'm not sure what project I installed it in. Oh, I installed it in this project. I wanted to do in that one. So I don't actually need in here, but I do need it in here. Yeah. Okay. Eventing basic consumer also is part of the library. Get rid of all the errors. Okay. Now, encoding also. Let's put that. All right. So we're going to need this because these are things that need to be disposed. They won't be disposed, of course, in here. They'll be disposed in the stop. So I need to extract these out and have them as local private members of this class. So this is an I connection, and this is an I model. So connection is connection, and the channel is a model. So let's do that. Call this channel. All right. So then we can pick that out. Take that out. And this channel is everywhere. Okay, another thing is this, the console or write, I'm going to have to modify it to the logger. So which means we'll use this logger here. And we'll start converting this console or write to using the logger. So logger dot log information. Just take all of this stuff here. Put it in there. Another thing you want to see is, or I wanted to mention was this. When you implement that worker, the default worker that was created, for example, and when you start a new worker service project and you get this code created for you, right, with a while loop and everything, basically like this. These were something I implemented. Okay. Don't write your code in here in this ExecuteAsync task. The idea of, or the best practice would be to take your code, call it from here. So you implement all of your functionality in a separate class or classes. And then from here, you in turn call execute or start and stop. Don't write the code in here. That way you can reuse that class in many other places. And it's not about reusability, it's about mainly decoupling your worker, the actual host, if you will, from your perspective, the background service and the stuff you do in your application. Right? So you can take that and move it to a console application or a web application and so on, instead of writing that code kind of right in there. So in our case, of course, because we are now having a separate library here, this the Rabbit subscriber is just in a class by itself. It is a descendant of background service, but it's not sort of hooked into that worker infrastructure. It is completely separate. So now that we have that, I'm going to, okay, we need to execute. So let's do this. Let's, that connection also is, all right. So now here, once we have this, the consumer tag, what type is this? It's a string. So I'm just going to take that consumer tag and make it also private member. Okay. All right. And then once you consume, you can convert this to logging. You need to take this as the kind of the undo the consume, right? That's really what happens. The consume will kind of block here. This event gets fired for every time a message is received. And when finally the thing finishes here, your application, it'll do that. So this is more like the dispose part. So we don't need that. You don't need that. And here we'll implement where's the iDisposable gone? Oh, stop. StopAsync. So here we need to do that. So now in the channel and between the channel and the connection, I'm going to dispose both of them. So the channel, once I do that, channel.dispose or close, I guess we can use, and the connection dot close. There's some sort of a dependency between these two. One or the other gets closed, but for now you just leave it like that. In other words, if you close the connection, it also closes the channel or something, right? So, but I'm closing the channel first and then closing the connection. Okay, so that's that. Now this background service is a background service, right? And so it has the ExecuteAsync here, and it has, we implement also the StopAsync, and we call the base classes method here. Now here, what we could do, since we have to return a task here, we can do the return task.completed task, or we could keep it in a loop. Let me change all these logger. Sorry about all this time. Maybe I'll just fast forward it depending on how long this actually takes. Okay, that's that. But as you know, the ExecuteAsync doesn't have to wait. You don't have to block it in this method for it to continue. So it'll just keep running. And we do need to return a completed task. And then now you might want to do in such a way that depending on this constant, the stopping token here, you might want to use that token in a loop and say, while it's not canceled, like do something. And as soon as it's canceled, you can do something else in this method, or you just do it in the StopAsync method here, which is what I'm doing. So then here we should return a task. And so that's what we shall do. Completed task. All right. Now we can register this worker service with our console application, which is here. I already did that. Okay. I forgot I did that. All right. So that's that. Then let me remove this worker. I don't want this. So right now we're just working with the RabbitMQ subscriber. That's our RabbitMQ subscriber class here. Don't need all these things. Okay. Okay. So we can put a breakpoint here, make sure it starts, not that it won't. Okay, there it is. Connect to Rabbit. Okay, so as luck had it, I had the Rabbit instance running in my Docker here. So if you look at the Docker desktop, the Rabbit instance is running. So it actually was able to connect to this instance. Okay, so we lucked out there. So it's going to start with that and try and connect. So nothing's publishing messages yet. So let's open up the management, RabbitMQ management, and take a look at that. Okay, so in the queues, we're looking at this queue. So now this queue's got no messages in here right now. So it's got 0 messages, nothing's being worked on, no acknowledgements, no publishing is going on here. And there are no messages in the queue. But we are listening on the queue. So let's do this. Let's use our other publisher application now. This one. Let me make this thing the active application, the startup application. Okay. All right, so it would have published this message. I mean, this thing has already received the message here. So when it starts up, it publishes one message, and we can see here it's received the message. And now what I'm going to do is that each time I hit enter on this console application here, it should publish a message, and we should see that message being received over here. There. So enter, 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 and so on. Each time I press enter, we see the message being received over here. And if I keep this enter key pressed on the console application here, all the messages are being received over here. If you go to the RabbitMQ management, you can see lots of acknowledgements taking place here, but 0 messages are left behind in the queue. Right, so that's cool. So the app's working. Let's make sure when we shut it down, it doesn't blow up, in case we made some mistakes in the dispose part. And then we will make this application a Windows service. All right. Okay, so let's shut that down. No problems there. Let's shut down. Our publisher can sit and wait. That's our publisher app. We'll keep all this running. No need to keep stopping and starting these apps. All right. So now, how do we make this a Windows service? We need to include another NuGet called Windows Services, I think. So Microsoft.extensions.hosting.windows services, I think. And then we need to add that using your users in the console application. So let's find the NuGet. And this one, Windows Services. And once you do install that, that's that. And then in our program CS file here, we need to add a use Windows service. That's it. Once you've done that, this can now be made into a Windows service. However, you still need to do a few things. You have to still install that service in Windows. This is not going to do it by itself. So what we're going to do is we're going to publish this application as a sort of a standalone application with all of the requirements within a certain folder. And then we're going to use the command line and we're going to register that application, this application, with the Windows service infrastructure so we can start, stop, and do all the stuff with it there. All right, so let's do that. So first is you need to publish this application. So if you were to publish that. I didn't pick that up. Okay. We have various options to publish. I want to just publish it to a folder on my local machine here. And it's going to publish it to, I'm going to leave that alone. No need to touch it. Basically, it's going to add on the publish folder in addition to this .NET 3.1, which is fine. Okay, we can look at some of the configuration options here. It's going to do the release build, blah, framework dependent. Maybe we should deploy this as a standalone, self-contained. And maybe since I'm running on Win 3064, make that. Okay, let's do that. Now we've done that, we publish. Take a few seconds. And it's published it. Okay, why doesn't it take me to the path? All right. So let me go back to this publish here. What did I do? Oh, okay. Now it's showing me the file path. Okay. So here's the whole project deployed with all of its dependencies in this one folder, and that's the executable here. Now I'm going to use the command line, register this application as a Windows service, start it, stop it. And when we start it, it's listening for the messages, publish messages, and see. Now there's no UI I can show you for Windows services. So we're going to use a trick. We're going to use the management, the RabbitMQ management console to see that messages are being consumed when we start the application, this service, and they're not consumed when we stop it, right? All right, so let's start a command line app and as administrator. And I'm going to use the service control module or service control, what do they call it? Service control manager. Okay, let's see. Let me make the font a bit bigger here so you guys can see what I'm doing. 828, okay. Wow, that's big. Okay, hopefully you can see that. So this SC command is the service control manager. And using this, you can do a bunch of things. You can start a service, you can pause a service, you can stop a service, but we need to first create a service. Create a service before we can start, stop, or pause it. So we're going to first create a service. And once we've created a service, we can also delete the service once we want to remove it from the Windows services registry. Okay, so I don't know what the command line for create is. So I'm going to say sc create and enter again. And it's going to say, well, in order to create a service, you need to provide it the server on which you want to create it. In this case, is local, so we'll skip that. So sc create, the service name. This is the name you want to see in your services kind of UI in Windows. It's not the name of the executable, just the name that you would like to use as the service name. The path to the executable. All right, so we do sc create. I'm going to call it RabbitMQ subscriber. That's just a name. And the bin path is wherever this thing is. I'm going to copy this as path and paste it there. All right. So that's created the service. If I went to the services console here and looked for RabbitMQ, you'll see it here. So it's there, but it's now started and it's manual. So I can, of course, right click here and say start or click the start there or whatever. But I'm going to start it from the command line here. So we'll say, so instead of create, we'll just say sc start that service. And this is, what did it say? Start pending. Yeah. So it says start pending, but basically it has started. It doesn't assume it's not going to wait on for it to start. So now if I refresh this, currently it says manual, whatever, but if I refresh this, it should say it's running, and now it's running. Okay. So now that this is running, let's start publishing messages again using our other application, this guy here. And we monitor the RabbitMQ console here to make sure, one, that these messages remain 0 and the number of acknowledgements goes up as we publish messages and the service picks it up. Make sense? All right, let's try it. So back in here, I'm happily publishing messages. I just got the enter key pressed down here. And hopefully in the next 5 seconds, we're going to see the number of messages remaining 0, but the number of acts have gone up. The acknowledgements have gone up, but the number of messages in the console are showing as 0. Right? Remember, this is refreshing every 5 seconds, so it's not instantaneous. But the acknowledgements went up, which means we've acknowledged a bunch of messages, over 15, 16 messages a second, almost, yeah. Right, so I'm going to start doing it again. Press the enter key, and that's it. Now let's watch this again. The next 5 seconds, again, the acknowledgements should go up and the number of messages should still remain 0. There it goes up and 0. All right, now the next step is if we shut down the service, if we stop the service and we publish messages, the messages should accumulate in Rabbit. And once you've done that, then start the service and the messages should disappear. Okay, let's try that. So on my Windows thing here, services panel, I'm going to stop the service. It's running currently. I'm going to stop it. If you get an error when you start or stop those services that you build, there's potentially a problem with the way you built that service. And so you should never get an error there. It's not okay to get an error, even though it may stop the app or may start the app. You don't want errors at that point in time. Okay, so we do that. And now we publish messages again. We just kept the enter key pressed. Come back here. So now we have 93 messages sitting in the queue for us and no acknowledgements. The green is those acknowledgements. So there's 14 messages. This is the publish. So publishes went up. Now we have 93 messages in the queue, but nobody's been subscribing. So therefore the messages are sitting here in the queue. Now, all I'm going to do is just start that service, Windows service. And you can set up these services to start up when the application starts up. So you could say something like, instead of manual, you can say automatic. So automatic really means it's going to start automatically when the operating system boots up. So each time your machine boots up, you can have a service running by automatically. Maybe I don't want to do that here, but I can start it. So I start that, and you'll see now at some point the number of messages here disappears from 93 to 0. There, gone. And so we know our service is working. So this is, so far the service has been working as a console application or a hosted in a console application. Remember, there's an application that's hosting the hosted service, right? It's a hosted service. All right. We're going to take that assembly now, we build the standard .NET standard assembly, take that and use that from a web application. And then we're going to contrast some of the differences between a console application and a web application in terms of the hosted services being hosted in a console application or a web application. Before that, I'm going to shut down the service and uninstall it or delete it. So let's do that here. Oh, sorry, in the console command window here. So instead of doing a start, I can do a stop here for the service. And then once it's stopped, I can do a delete. And that's that. If I look at the services now, you notice that it's there. When I refresh it, it's gone. Right? So it's no longer registered. Cool. So that's that. All right. Don't need that anymore. I'll keep this running still. I'll keep that running still. Actually, we don't need it, but I'll keep it running anyways. And don't need that. All right. Now, next is to add a ASP.NET Core project to this solution. Core application. And it'll just be, API application, let's say. So there are two ways to do the registration of a worker service in the ASP.NET Core application. One is you can go to Program CS and do the same thing like we did before. So I'm going to open, this is the Program CS from our previous worker service application. And this is the Program CS from our, let me just open the, okay. So this one is our worker service application. Sorry, this one is our worker service application that's already registering the RabbitMQ. And this is the ASP.NET application. Just look at the two sides here. you can see they're almost identical. This is something we added recently. So, but you can see here, this says configure web host defaults, and this one just says configure services. That's it. Now we could add like what we did here, configure services. We can take this, as it is and do it in there. Right, and that'll work. Kind of like that. We still need that, what do you call it? The hosted extensions here to be able to do that part here. So let's do that. In an ASP.NET application, I thought it was explicit. Sorry, I thought it was implicit in ASP.NET, but maybe not. Okay, now. Okay. So now that we have that, there's something to keep in mind here. If you do it in this sequence here, you're saying that you want a hosted service to be registered after the pipeline. Maybe sometimes you want it to be done before the pipeline. Sometimes you want to do it after the pipeline. So the simple way to do that would be just to switch the order of these two, right? Move them up, do one before the other kind of thing, like that. Right. Like that. Right. But if none of that matters, then I would suggest don't do it in the program CS for your ASP.NET application. Just do this registration in the startup. So I'm going to take this out of here. Both ways work, either ways works. So I'm going to now open up the startup. And in startup, you already have a configure services method here. So we just do that there, right? That's that. And that's all you need to do. In an ASP.NET application, the infrastructure already exists. So all you need to do is just register your own hosted service. SignalR is one of those services that runs as a hosted service in an ASP.NET application. So it's something that a lot of the framework already uses, and they've just exposed that to us. And as I said before, it used to be iWebhost. Now it's just iHost. So they're independent of anything web related in terms of the infrastructure for the web, like from a service standpoint or a server standpoint, which used to be the case before, not anymore. All right. So we're taking the same class here that was in the standard .NET Standard library, and by the .NET Standard is disappearing, you know that, right? Yeah, in .NET 5, there's no notion of .NET Standard. That's it. .NET 5 is it. Okay, so let's run this application and see this background service running. So do we have messages in the thing here? We don't. Okay, doesn't matter. We shall run this application and check it out. Oh, this is the worker service. Sorry, wrong application. Let me create this as the startup application. Okay, and run it. So that's the API part of it, right? I'm going to publish the messages here, and we shall see if they are being acted and consumed by our publisher. So they've been acted. You can see it went up here, and the number of messages in this will be 0. Right, so you know it's working. Now in ASP.NET Core, you have another way to see this, because you can run it as you can run the application rather than you running it within IIS Express, right? So you can run the console application where you see the console window and the logger output will be visible to us there, and instead of running it in IIS Express. So let's do that. So I'm just going to shut this down. And here, instead of using IIS Express, I can use the service itself, the application, and this will show us the console. So now you'll see our own console window here, and you'll also see the events being published here for when we receive messages from our publisher, right? So there, I hit enter, it's getting published and sort of being received here, subscribed here. Enter, 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 keep the enter key pressed. And there you go. All right, so we've gone through the whole thing. We've looked at a plain Jane worker service. We've built our own class that descends from nothing, but just implements the IHostedService and the iDisposable. We've used the background service base class to do our own thing, to build a RabbitMQ worker service, which is a full-fledged implementation. We've taken that implementation and used it in a console application and in a ASP.NET application and seen everything working. We've also installed that application, the console application, as a Windows service. So we pretty much covered all bases here. Just keep in mind the units of scale aspects of a service, even though this is a cool feature, it's not normal or always true where your background services have to scale at the same units of scale as your application. And maybe sometimes that even causes you trouble. So think about those aspects when you're building a background service. But if you're just building a background service, you don't need it to be in an ASP.NET application to start with, right? You could just have it as a console application and do it that way. All right. So that brings us to the end of this video. I hope you've enjoyed yourselves. I hope you learned a few things. If you have, please give me a thumbs up and I will see you next time.